Okay.
My mom is too.
She was just listening to it. She was saying it.
Greetings and welcome, friends. We are talking today about verifying trigonometric identities. Again, part 2, that's right. How great is this? And I just want to have us look at a handful of examples, less than a hand, I guess, 4 out of 5 fingers. That's fine. Just give us some more practice with some additional trig identities today, as well as some of the additional algebraic techniques that maybe we need to practice up on. So this says verify that cotan of negative theta is equal to negative cotan of theta. Right? So now you might remember we had some identities, the opposite angle identities, but those only technically applied to sine and cosine. All right, so perhaps the first thing I might want to do is use a quotient identity and rewrite cotan in terms of sine and cosine. So remember, cotan theta is equal to, cos over sine. Because it's the reciprocal of tangent, of course. So I could rewrite this as cosine of negative theta over sine of negative theta. Right? Right-hand side we'll leave alone for now. And cosine of negative theta, I believe that is one of my opposite angle identities. Op-ang idents. Right? And let's see, what were the opposite angle identities? We had that sine of negative A was equal to negative sine of A. And we had that cosine of negative A was equal to the positive cosine of A. Because in the case of cosine, if I have an angle in the first quadrant, the negative angle would be in the fourth quadrant, and cosine's positive in both of those. Or if I had an angle in the second quadrant, the opposite of that would be in the third quadrant, and cosine's negative in both of those. So cosine agrees with itself for opposite angles. Sine disagrees with itself. So that means I would be able to use this and this to replace this and this, right? So cosine of negative theta should equal the same as cosine of theta. And sine of negative theta is going to equal negative sine of theta. And then I can use the quotient identity again backwards, and I believe that's just going to equal what we're looking for. Right, so that's just negative cotan theta equals negative cotan theta. All right, so main reason I wanted to show you this example was just that some of our other identities will be showing up that perhaps you don't recall completely. Right, so just using some of the ones that aren't just the reciprocal quotient or Pythag ones is the idea. So let's do another problem. Cruising right along. Example, here we are. Ooh, I like this one. I like it a lot. So based on that 360, we can assume that x is measured in degrees instead of, radians. So looking at this, boy, friends. Yeah, this whole cosine of 360 minus x, that's going to be one of our symmetry identities, or symmetric. All right, and what symmetric identity do you think that lines up with? What do you think we got? Cos of 360k minus a is equal to what? Cosine of a. All right, so yeah, so this should just be a straight replace. So I'll have cotan x times cosine x equals, maybe we'll leave the right-hand side alone for now. What else should I do on this left-hand side, you think? I mean, yeah, I'm thinking it might be valuable to write this all in terms of sine and cosine, because the right-hand side's all sine, the left-hand side's already half cosine. Yeah, so let's replace that with its quote identity. So that would be the same as cos x over sinx times cos x. And multiplying across, what do I end up getting there? Cos squared x over sinx, yeah. All right. How about on this right-hand side? I mean, I could actually tweak this and make it equal to that fully, or I could work on the right-hand side. Doesn't matter to me. I think there's, what do you think's in store for us? I mean, I'm seeing some squares. Yeah, Pythag jumping out at us. Sine squared theta plus cos squared theta equals 1. So what could I do to rearrange this? Yeah, subtract the sine squared from both sides. I ran out of room. That's fine. So I'll get cos squared theta is equal to 1 minus sine squared theta. So this is what I'd call a modified Pythag, a mod pi, right? And where should I replace? What should I replace? I could replace this here with 1 minus sine squared, or I could replace this here with 1 cosine squared. I guess I've been working on the left-hand side. We'll just keep at it. So 1 minus sine squared x over sinx is equal to 1 minus sine squared x over sinx. Verified. Good stuff. So symmetric identity showing up there. Keep an eye out for that. Those don't happen as often, but they can. Who knows? Who knows? Let's see. I think I can fit another one down on this. And here we are. Nice. This will be using a little bit of algebra. Aha. Secant x minus tan x, all in parentheses, multiplied by 1 plus sine x equals cosine x. So yeah, one of the general strategies we outlined yesterday, we said that typically you might want to maybe work on the more complicated side and simplify it, right? Try to bring it towards the simpler side. So I have no, substitution for 1 plus sine x. I don't have a substitution for this. So I think we're just going to multiply this out. Yeah, I think let's just try foiling it. So double distribution. So secant x times 1 is secant x. Secant x times sine x would be plus secant x times sine x. And then multiply the negative tan x by both of those. So negative tanks and negative tanks sine x. Oh, that's a multiplication there. Equals the same thing. I'll leave that blank for now. I imagine it's going to just probably be the same the whole way through. All right, so, guys, what do you think we should try here? Cross out. Oh, no. I think we'll just. Well, there's no like terms just yet. Because this is like an entire term, right? This is a term. So unless they were both tanks, sinks, or something like that, I couldn't do that. I think what we'll try is rearranging this so it's all in terms of sine and cosine. So we'll just swap out that, and that. And hopefully we're getting pretty familiar with these. So this would be the 1 over cos. Oh, maybe. Oh, ooh. Huh. Wait a minute. Oh. Well, secant x is 1 over cos and I'm multiplying by sine x. So that's going to just end up in the numerator. But this guy, sine x over cosine x, is the same as what? Tangent. So this whole thing will probably end up canceling out with that. So I might not want to replace that. Although if I did, let's just say I did because I didn't realize any better. It'll still cancel out. Minus sinks. Okay. So I'm going to say this cancels out with that. All right, because when I multiply it, it's sine x over cos x minus sine x over cos x. Those cancel out. And I will have, what's this? 1 over cos x minus, what's this multiply to be? Sine squared x over cos x equals, same thing, same thing. What are your guys' thoughts on this here? We could, because I still have this equal to cos x. I could kill all the fractions there. Yeah, that's nothing wrong with that. Definitely a good strategy. In this case, I realized that these have a common denominator, so I could just write this as 1 minus sine squared x over cos x. Your strategy would not have been wrong. It would have led you to the same answer, or same conclusion of it being verified. And then I think this is a modified Pythag right here, right?
Yeah, it's equal to cos squared x.
Yeah, I just wanted to go this route because I thought this last little step looks kind of cool-ish. Because what happens here? Right, the cosine x in the denominator cancels out with one of them in the numerator.
I know, and you go home and you forget.
It's not like you forget everything, it's just like I don't know what strategy to use, so I just
Yeah, that's kind of.
Yeah, so it's just a matter of like keep tinkering with things a little bit, see what you can do, and see where it takes you, sort of thing. So yeah, it takes a little practice, and that's why I wanted to just show you some more examples today, and then give you time with partners to be able to work on some of these as well. So let's see, one more example we'll do after this. One more. Zoop, zoop. Exemple. Here we go. Oh, I like this one. I like all of them, guys. I don't know, the idea of like switching things out and like rearranging, it reminds me of like some sort of iPhone puzzle game of like, oh, I can switch these parts and then eliminate that. It's like, you know, a match 3 sort of, I don't know. I think it's kind of fun almost.
really just like Candy Crush and
No. So let's see, 1 plus sine x over cos x plus cos x over 1 plus sine x. If those were multiplying, those would cancel out real nice, but they're not, sadly. Equals 2 secant x. So the first thing I think we'll do, because notice like 4 out of the 5 trig functions here are already sine and cosine. So let's just take it the rest of the way and see what we get. So what does the secant x replace with? Yeah, so that's 1 over cosine, or I'm just going to write this as 2 over cos x when I multiply that out. Now, question, why can't I cross multiply? Because I've got this plus sign here, right? If this was all like one fraction, then I could cross multiply. Or if this was like not here, cross multiplying would probably be a good technique. All right, but that's not the case. So because I've got multiple fractions with multiple denominators, I'm gonna find the LCD, I think, and just multiply both sides by it. So what do you guys think the LCD is here? Perfect. Cos x times 1 plus sine x. And let's see what happens when I multiply both sides by the LCD. Because the goal of killing the fractions is it's going to make the problem look simpler. Hopefully, be able to make some other moves more apparent to us. So remember, when we're multiplying here, this whole left-hand side is going to be distributed.
When you do this, is it the LCD over 1 or LCD over LCD?
LCD over 1, technically, yeah. So good question.
Oh.
Yeah, good question. Yep, and that's actually way back in Math 3 days. That concept is one that kids very easily mix up right there. So because yeah, multiplying both sides by the same thing is a legal thing to do. Technically, I could multiply top and bottom, but that wouldn't get rid of the fractions for me. So let's see, multiplying the LCD by this fraction here, what part would cancel out?
The 1 plus
The cosine x would cancel out, and I'd be left with a 1 plus sine x times the 1 plus sine x, right? So I'll write that out like this. 1 plus sine x times 1 plus sine x. Wait a minute. I could just write it like that. Interesting. You don't have to write it like that. You could leave it the other way and then FOIL it. Let's see, multiplying the second fraction. What cancels out? The 1 plus sine x with the 1 plus sine x, leaving a cos x times a cos x. So that's going to be plus what?
cos x squared.
Yep. And on the right-hand side, the cos x and the cos x, leaving a 2 times the 1 plus sine x. Now, one thing I'm going to want to point out about this, it being a while since you've used some of these algebra skills, you might be tempted to do this. And that is super illegal. You cannot distribute an exponent over addition. However, it turns out there is this pattern, a plus b all squared is equal to a squared plus 2ab plus b squared. Aha! And that would be helpful. If you didn't write it this way, you could have just had 1 plus sine x times 1 plus sine x and just like foiled it normal, and that would have been fine. All right? There's nothing wrong with that. The pattern's just a little bit quicker is all. So let's use the pattern on this. So 1 squared is 1 plus 2 times sine squared x plus sine squared x. Equals, and I guess do you think I should distribute this 2 over on the right-hand side? Yeah, well, why not? And I could technically wait to decide to do that, right? Depending on what's coming together on the left. Okay, does anyone see anything helpful here? What's this? Oh, there is 3 sine squared x there, but that would actually have ended up being,
That equals 1.
yeah, this whole thing is equal to 1. You're right, this was a like term with that. You're right, but looking at this right-hand side, I realized I don't have any sine squared x's here. Or wait. This one shouldn't be squared. I'm sorry. That is a typo. When I did the pattern. My bad. Right, the pattern, notice it's not squared up there. My apologies, friends. Okay, but those would have been like terms. Okay, and then looking at this right-hand side, you could see like, wait a minute, I don't want any sine squared x's or cosine squared x's, and hopefully seeing this would jump out at us. Right, that is equal to 1. And so let's see, 1 plus 2 sinks plus 1. I don't think that's even that hard to see what we do now. We just 1 plus 1, guys. You're complaining this stuff is so hard. I don't understand. Verified. So yeah, using some of our fraction techniques from back in the day, definitely helpful. Definitely helpful if we're trying to simplify this. So thanks for watching, internet friends. Have a great day. Bye-bye.